Rohit, how was the weekend? How was the weekend? Good, huh? What generally what do you do when you get on weekends? Oh, they give an assignment, huh? Generally, what do you do on Sundays? Sleep. Oh. Do you play any games? Play some games, no, to make you active. It's like not like some badminton or something like that. Even if you study every time, also it won't be so effective. Go out and have some time. Today we start a coordinate geometry. Coordinate geometry is over for you, the school, yeah. What about for you? Not sure. Listen to this class properly, okay? Your triangles, you almost missed it, right? This also you listen properly from the beginning. Very easy, okay? So what have you learned in ninth class about coordinate geometry? Cartesian plane, x coordinate, y coordinate, graphs. Uh. Generally, why this coordinate geometry is used? For what purpose? To find area, distance, right? Distance between 2 points. Uh, what else? Kaushik?
Yes, sir. Yes, sir.
So who else is there? Venkat?
Sir, is it?
Yeah. So as much as possible, please come, yeah, offline class.
Okay, sir.
Yeah, it will be beneficial for you only, yeah. So online, you won't get much. Okay, Kaushik.
Yes, sir.
So yeah, like what do you know about coordinate geometry? Can you say something, Kaushik?
So plotting the graphs, coordinates, different
Sorry?
coordinates. Different coordinates for. Sir, we have 4 quadrants in a graph.
Yeah, we can plot the graphs.
We have 4 quadrants in a graph, sir.
Nana. It's a like using coordinate geometry, we can measure the distance, but that's not just a complete coordinate geometry. So one of the things of coordinate geometry. So Venkat, what do you know about coordinate geometry?
Sir, it is placed in graph.
Yeah, graph. What kind of graphs? 2D, 1D, 3D.
Sir, 2D.
Sorry,
2D.
2D, right?
Yes, sir.
So what are the graphs basically that you can draw in 2D? Give me some examples.
The bar graph.
Rohit, what are the graphs that can have in 2D? Yeah, bar graph, histogram, pie chart, line. Line is in 2D, right? Circle, triangle, huh? Triangle, stock, sir. Right. Or even a heartbeat. Heartbeat is represented in 2D, right? What else are some real applications that you see? Yeah, like all the shapes. So parabola, hyperbola, right? This all you can plot using this 2D coordinate geometry, right? But then you can measure the distance between the 2 points, and you can measure the area under the curve. Area under the curve. Let's say this is the curve. You can measure the area under this one. Okay, and you can measure the distance between the 2 points or any number of points. Okay, and metry means generally measurement. Metry means measurement. So using this coordinate geometry, we can do some measurements, right? So it can be finding the length or finding the distance or finding the area, right? So what is here? There is something called x-axis, right? And so what is x-axis? X-axis is also there will be x coordinate, y coordinate. So let's say if I mark this point as 2, 3. What is x coordinate here? Coordinate is y coordinate is 3. So x coordinate is nothing but the distance from the y axis. Huh? The distance from the vertical axis. That's x coordinate. The distance from the horizontal axis is y coordinate. Y coordinate. So also this is called x coordinate is called abscissa. Abscissa. Y coordinate is called ordinate. Right? Sorry, ninth. Huh? Oh, okay. Very simple things, yeah. So all the points on x-axis can be represented as x comma 0, because always y coordinate is 0, right? So all the components on y coordinate can be represented as 0 comma y, because always x component will be 0. Okay, so can you do this exercise? So what they're asking is, do you have the graph with you? From tomorrow bring the graph. Okay, tomorrow bring the graph. So for now just mark the point simply. Okay, so just I will say some points, you mark them on the graph. Point A is 4 comma 8. Yeah, plot it on the graph 4 comma 8. 4,8. You mark it. So how much is the x coordinate? 4. Y coordinate is 8, right? So mark the next point as 3, 9. What is the first point? 4, 8. So this one. Okay. Next point is 3, 3, 9. This is this. Okay. So third point is 3, 8. Okay, these are 3 points. Let's say take first point as A, second point is B, third point is C. Okay. Now take a D point as 1, 6. 1, point D. Okay. Point E is 1, 5. Point F is 3, 3. E, F. Point F is 3, point G is 6, 3. Point G is 6, 3. And then point H is 8, 5. Point H is 8, point I is 8, 6. Point I is 8, 6. And then point J is 6, 8. Point J is 6, 8. Point K is 6, 9. Mark it. Point L is 5, 8. Point L is 5, 8. Okay. So what they are telling, first you join the points A to B, B to C, C to D, D to E, E to F, and then K to A again, L to A again. Did you join the points? A to B, A to B, and B to C, and then C to D, C to D, D to E, E to F, F to G, F to G, G to H, okay, H to I to J, and then J to K, K to L, L to A. Is it right? Or something wrong? H is what? 8 to 8, comma 6, right? H is 8, comma 5. Okay. Now, what we have to do? D, E, F is 3, comma 3. So, and then now, then join the points 3.5, comma 7, which is 3.5, comma 7, 3.5, comma 7. So it will be somewhere like this. Okay, 3.5, comma 7, and then 3, comma 3, 3.5, comma 7, 3, comma 6, 3, comma 6, and then 4. This is 3.5, comma 7 is P, point P. Okay, this is point Q, and then R point is 4, comma 6. Now we need to join them to form a triangle. These 3 points. Okay, did you join? You need to show to me, hurry. Finally. Next is also join the point 5.5, comma 7, 5.5, comma 7, 5, comma 6, 6, comma 6. These are points X, Y, Z. X, Y, Z. Join the points. Again, these 3 to form a triangle. Okay. Now join 4, comma 5, 4, comma 5, and then 4.5, comma 4, and then 5, comma 5, and then form a triangle. Okay. So lastly, so these are the what points? S, T, U. Yes. T, U. So lastly, join S, to the points 0 comma 5 and 0 comma 6. Where is 0 comma 5, 0 comma 6? X is 0, y is 5, 0 comma 6. This is, yes, we need to join to the, yes, right? Yes is where? This one only, is it? Am I drawing right only? And join u to the points 9 comma 5, 9 comma 6. 9 comma 5, 9 comma 6. What is this picture? Cat, huh? Hari? Did you get this cat? Show me your cat. Hari. Rohit, show me your cat. Huh? No. You got a better cat. Did I miss some point? What is F function? F is 3. G is, here is wrong. Mine is wrong. G is 6 comma 3, right? G is 6 comma 3. This is, yeah, this is right. Oh, you can see the cat. Good. Now it's a cat. Okay. Like this, you can draw any figure. You can draw your face also, right? Hari, your face also we can draw. Okay. Show me. Very good. Okay, Hari, interesting. Next. Okay. Just it's for fun only. Also, we have completed the chapter linear equation in two variables, right? How it will be? What is the general form of the linear equation in two variables? Linear equation, not a quadratic. Ax by plus c equal to 0, where a comma b are not simultaneously 0. One can be 0 at any time. One can be. A also can be 0. But in terms of quadratic equation, a cannot be 0. X square plus bx plus c equal to 0. That's a quadratic. Okay. But here, either a can be 0 or b can be 0, but it cannot be both. Okay. So this can be represented graphically, which gives us straight line. Also, we have seen the graph of y equal to x square plus bx plus c, where a not equal to 0, which is for parabola, which is parabola. So how it will look like? Or it can be like this also. Okay. This is y equal to x square plus bx plus c. Ax plus by plus c equal to 0 will be like this. Ax plus c equal to 0. Right line. So coordinate geometry is nothing but studying the geometry of the figures. Studying the geometry of the figures. So in this chapter, we will learn how to find the distance between the 2 points. What are the things we will learn? Distance. Note it down, hurry. Distance between the 2 points. Whose coordinates are given. Whose coordinates are given. And also find the area of the triangle formed by 3 given points. Also find the coordinates of a point which divides the line segment joining two given points in a given ratio. So these are the things basically we study in this coordinate geometry. We can do many things, but this chapter is only limited to only these 3 things. What are we doing here? So the first one is, let's say the 2 points are given. Then we'll find out the distance. Point A, point B. We'll find the distance between the point A and point. That's the first thing. First thing we do. Second thing is 3 points are given. A, B, C. Then we find out the area. So what are the, let's say here point, take out points as A equal to x comma y, B equal to u comma b. Then we find out the distance between the 2 points. So here let's say A is equal to x comma y, B equal to u comma v, C equal to some s comma t. Then we find out the area found by these 3 points of the triangle. This is second thing. And the third thing is, let's say line segment is given. Line segment is A, B. Okay. A is x comma y, B is let's say u comma v. This is the line, given line segment. So, and there is a point on the line. There is a point on the line which divides this line segment in some ratio. Let's say 2:3. Okay. Then we need to find out the point C coordinates. That's the third thing. Did you understand the third point? What is the third point? One line. There is a line, okay, line segment, and then there is a point which divides the line segment in some ratio. Let's say 1:2, 2:3, 3:4, whatever the ratio. Some let's say m is to n. Then we will find out the coordinates of that particular point C. So here, what is the distance from A to C? Not m. It will be m into some constant, m into k. The point from C to B to C will be n into k. Then only ratio will be m is to n. We should not say the distance from A to C is m, the distance from C to B is n. You should not say that. Because that's not the absolute distance. The ratio is m is to. Okay. This is what we find out. If this is a ratio is given, what are the coordinates of point C? These are the three things we are finding out. Tell me the again. What is the first one? Distance between the 2 points. If 3 points are given, then the 3 points will form a triangle. Then find out the area of the triangle using 3 points, and then there is a line segment. There is a point which divides line in some ratio. Then we need to find out the coordinates of that point. Hari, you also did say 1 to 3 points. 2 points. Right, very good. Can you say it without seeing now? What did you understand? Good. Got it? So what is the first one now? We need to find out the distance. Distance between the 2 points. Okay. So distance formula. Okay. So let's consider the following situation. Let's take x-axis and y-axis. X-axis, capital X, y-axis is represented with the capital Y. Rotations are also important. X-axis is represented with the capital X. Y-axis is represented with the capital Y. Coordinates is represented with small x, small y. Coordinates represented with the small x, small y. Okay. So here let's take, here is a point A. This is called origin. 0, 0 is called origin. Origin. Okay. So a town B is located 36 kilometer east and 15 kilometer north. Let's take this is east, this is north. Okay. So it is located 36 kilometer towards east. This is 36 kilometer and 15 kilometer towards north. Okay. So the point will be here. The town will be, this is town B. Got it? So this length is 15 kilometer. Hurry. Getting? Focus on the class. You will understand much better. Okay. If you miss the for these classes, you won't understand anything. So if you draw a line, okay, from A, from town A, there are two towns. Okay, town A, town B. Town B is located 36 kilometer east, 15 kilometer north to the town A. So that's why we are taking town A as a reference, and towards the x direction will be east, right? Towards the y direction will be north. So and then we are pointing out the point B. Now we need to find out the distance between the two towns. So means the distance which joins point A to point B. We need to find out the AB, distance AB, right? Without actually measuring it. So this is how we can represent in a graph, right? It's a graphical representation of how town B is situated with respect to town A. So one thing is, how can you get the AB, length of AB, using a Pythagoras theorem? You can use the Pythagoras theorem to get a length, right? So now, suppose 2 points lie on x-axis. Okay. Can we find distance between them? The 2 points are lie on the x-axis. Then can we find a distance between them? For instance, consider 2 points. A is 4, 0, B 6, 0. So are these points will lie on x-axis or not? Why? Because y coordinate is, you should not say y axis is 0. Y coordinate is 0. Okay, because y coordinate is 0. So these 2 points lie on a x-axis. So then what is the now draw one more figure, okay? Keep that figure like that only. Draw one more figure. Hurry, draw one more figure. This is capital X, capital Y. Hurry, drawing or not? Be active, hurry in the class. Very important class. One, two, three, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what is the points now? 4 comma 0, 6 comma 0. This is point A, this is point B. Let's take this origin as O. Origin as O. How much is the distance OA? OA equal to 4 units. OB will be 6 units. Okay. Then AB will be, AB means the distance between the A and B, right? Huh? So that is nothing but OB minus OA. 6 minus 4 equal to 2 units. That is the distance between the points A and B is nothing but AB. So if 2 points lie on an axis, we can easily find the distance between them. How? Just subtracting those values. It is 0 comma, if it is 2 comma 0, 8 comma 0, then what's the distance between the 2 points? 8 minus 2, 6. If there is, if the first point is 1 comma 0, second point, first term is x comma 0, x1 comma 0, second point is x2 comma 0, then what's the distance? Very easy. If the points lie on a x-axis, if the points lie on a y-axis. Okay, let's say point C is 0 comma 3, point D is 0 comma 8, 0 comma 3, 0 comma 8. This is very good. Yeah, so let's say it's 0. Got it? It is 0 comma y1 and other point is 0 comma y2. The distance will be y2 minus y1 or y1 minus y2, which is positive. Which is positive, we can take it. Okay, if y1 which is positive, we'll take it. If the points x1 comma 0, x2 comma 0, then distance will be x2 minus x1 or x1 minus x2, which is positive, we'll take it. So this is easy. When the point lies on a x-axis or y-axis, it is easy. Now join the points AC and join the points BD. Okay, join the points AC, join the points BD. Now how to find out the distance between the sorry? Yeah, please do, no problem. So let's say we need to find out the distance of A from C. Okay, we need to find distance A from C. Right? OA is how much? OA is 4 units. OC is OB is OC is 3 units. So AC will be, by using Pythagoras theorem, OA square plus OC square, 3 square plus 4 square equal to 5. Similarly, you can find the distance between from B to D. B to D, how can you find distance between BD equal to? OB square plus OD square. OB square is how much? How many units? 6 units. 8 units. It will be 10. Square plus 8 square will be 100. Square root of 100 will be 10. So now if we consider 2 points not lying on a coordinate axis. So here we consider the 2 points lie on a coordinate axis. Here point A is lying on x-axis, point C on lying on y-axis. Point B lies on a x-axis, point B, point D lies on a. So, but let's consider a situation where the points are not lying on a coordinate axis. Can we find the distance between them? Yes. We shall use Pythagoras theorem to do so. So there also we use a Pythagoras theorem. So let's see how do we do it. Let's see an example. Okay. In figure 7.3. Now take one more figure. Figure 7.3. Let's take a figure. Yeah, please. Figure 7.3. Okay, now first draw a figure 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. 0 origin 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now there is a point P. Point P is 4, 6. 4, so this is point P. Okay. And then point Q is 6, 8. Point Q is 6, point Q is 6, 8. So point is represented like this. Okay. P, let's say if point name is P, then 4, 6. Point name is Q, then 6, 8, like that we'll represent. P of 4, 6, P of 6, 8, like. So and then, so we need to find the distance between the points PQ. We need to find the distance between the points PQ. Okay, now let's see how can we find it out. Do they lie on coordinate axis? No, right? Point P is not lying on a coordinate axis. At point Q also not lying. So let us draw PR. PR is so which touches the coordinate axis. Okay. This is PR. Okay. Also, let's draw QS. Let's say take point as CS. Means dropping a perpendicular. Dropping a perpendicular. Okay. This is QS. And then, so these are perpendicular to x-axis, right? Both PR and QS are perpendicular to x-axis. Just we drop the perpendiculars. Also draw a perpendicular from P on QS. So this is at T. So now PT is perpendicular to QS. Then the coordinates of R and S are, coordinates of R is, what are the coordinate of R? 4, 0, very good. Coordinate of S is 6, 0, okay. And then how many units RS? RS is 2 units, right? RS is 2 units. So what about QS? QS will be 8 units, right? RS is 2 units, QS is 8 units. And TS equal to PR. TS equal to PR, right? TS equal to PR, which is equal to 6 units. What about QT? QT equal to 2 units. And PT equal to RS, right? Equal to 2 units. Now, did we get all the points now? So, let's consider a triangle PQT. Triangle PQT. So, how is the Pythagoras theorem can be applied? PQ square equal to PT square plus QT square. How much is PT? 2 units. QT is 2 units, right? 2 square plus 2 square. So, 8. So, PQ equal to square root of 8, which is equal to 2 root. That's how we can find the distance. So I will give you the general formula. Okay. So now, how will you find distance between 2 points in 2 different quadrants? Now these all are in the first quadrant. Let's say I'll tell you. This is x, y. This is plus plus. This is minus plus. This is minus minus. This is the first quadrant. Which is second? This one is third. Okay. So the first example is all points are in first quadrant. All points are in first quadrant. Okay. Now consider the one more example. Consider one more example where the points are in different quadrants. So let's draw one more. So please bring the graphs tomorrow, okay? One point is 6, 4. One point is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, one point is 6, 4, yeah. This is P. Okay. Another point is minus 5, minus 3. How much is x coordinate value? Minus 5. Y coordinate value? Minus 3. So other point is this one. Minus 5, minus. So now we need to find the distance between the points P and Q. Okay. What we need to find out now? Distance between the points. We need to find out PQ. So first, what we need to do? Find out PQ. What can we do? Any idea? So we need to first construct a right angle triangle. Construct a right angle triangle. Then you can find it. Okay, what is the right angle triangle here? Let's say This is the right angle triangle. So what we are doing? We are drawing a perpendicular Q to, let's say, this point S. Okay. Also draw a perpendicular PT from a point P on QS. Let's say QS, we are drawing a perpendicular. Okay. First, what we need to just draw two perpendiculars. That's it. One perpendicular is from Q. One perpendicular is from S. P. Okay. And then we need to measure this distance. We need to measure this distance. How many units? This one. So this is 6 units. This is minus 5 units. Total 5. This is 5 units this side, 6 units this side. So total will be 11 units. Okay. So this will be how many units? Top 4 units. Down is 3 units. Total 7 units. So now let's consider this a point T. So PQ square equal to PT square plus QT square. How much is PT? 11 square plus 7 square equal to 170. 170, right? 121 plus 49 is 170, right? Square root of 170 is PQ. So we found out through Pythagoras theorem. Basically, what we are doing. So now let's consider. So also, what else you can do? You can. So here vertically you have drawn a perpendicular. Here you have drawn a perpendicular to which axis? Is perpendicular to which axis? This one. QT is perpendicular to which axis? X axis or Y axis? So and PT is perpendicular to. So also you can draw perpendicular to Y axis also, and here you can draw perpendicular to also. From this also you can find out. You can do anything. From each point you draw perpendicular to one axis. From other point draw perpendicular to the opposite axis. If you are drawing from first point perpendicular to X axis, another point you need to draw perpendicular to Y axis. Like that you need to. And then you can measure the distance, and then easily you can see the distance. And using the Pythagoras theorem, okay. So how we are measuring a distance? So distance is nothing but, let's say, this is P point is. Let's take one more. Okay, one more triangle. X, Y, O. Okay, and there is a point P, point Q. So we need to measure this distance. Okay, point P is x1, y1. Point Q is x2, y2. Okay, and what you are doing? You are dropping a perpendicular. Okay, again perpendicular. Then perpendicular. This point is T. Okay, point is. Let's take this point is R. This point is S. Okay, so we need to measure PT and QT. Once you know PT and QT, PQ square is nothing but PT square plus QT square. Okay. So then this is the origin. Okay. So what is the OR value? OR equal to x1, right? OS is OS is OS is x2. Okay. So what is now RS? RS equal to OS minus OR, which is x2 minus x1. Okay, now we found out RS. Also, we need to find out RS is nothing but PT. PT equal to RS. So now we need to find out QT. Okay, QT. How can we find out QT? So what is SQ? SQ equal to Y2, right? What about ST? ST equal to Y1. Right or not? So ST is nothing but PR, no? ST is nothing but PR. So ST equal to Y1. So QT equal to SQ minus ST equal to Y2 minus Y1. So what is PQ square using Pythagoras theorem? PQ square equal to PT square plus QT square, right? So what is PT now? PT is x2 minus x1 whole square plus y2 minus y1 whole square. So then PQ is nothing but square root of x2 minus x1 whole square plus y2 minus y1. Okay, this is the distance formula. This is general formula. Whatever x1, x2, whatever y1, y2, which are the coordinates, which are the quadrants. So this will be applicable. So distance, if the points P is x1 comma y1, Q is x2 comma y2, then distance between the 2 points PQ is given as x2 minus x1 whole square plus y2 minus y1 whole square. So this is called distance formula. Okay. So we'll close for today. Yeah. So tomorrow we will solve some examples. So then we'll look at the area. Yeah. Now we found the formula for distance. So what else? Two more things are remained is one is the area of the triangle, and then find out yeah, on the points that divides the line segment. Then we find out the coordinates of the point.